Good afternoon, good morning, good evening, everyone. And, you know, sorry to skip over Dr. Vanda and surprised to see me before. So, my name is Ravit Sachasiri, working with Swedish Space Corporation, and the presentation is going to cover mostly about what SSC does, but also a bit about what SSC would be dealing with respect to the station frequency management, which we would normally do on the customer's behalf, but maybe a bit before we can do some introduction. So, Swedish Space Corporation, it is uh, well, it's a company, but fully owned by the Swedish government. So we work as a corporation, but we are fully owned by the Swedish government, and we work throughout the space value chain and being a service provider. The ground station business, or what we call the ground station services, what we call today SSC Connect, is the core services that we do globally. But additional to SSC Connect, we also do other services which are mostly aimed today in Europe, but we're looking to expand globally as well. We have maybe a bit of a history going, not history, but a bit of information about SSC. We have a launch site in Sweden, which we will have the first orbital launch next year. We have also two companies doing rocket testing, so including burn tests and engine tests and stage tests on our sites. That is part of our launch services. Additionally, on the right, we have spacecraft operation engineering services, which we do mainly out of Europe, Netherlands, Italy, Spain, where we are either working at the customer's base, providing operational service to them, provide consultancy to them, or providing manpower. So this is where a spacecraft operator, once you own and operating the spacecraft, you may want to have people who are doing operations, but don't want to be, you want to concentrate your staff on maybe developing the end product, which could be maybe knowledge and insights that you're gaining from the spacecraft, and then we would be providing mainly the service to operate the spacecraft. On the downstream side, we also have a service for space safety, or what we now call SSA, space sustainability. Some ways it's also called space defense, but I mean it's basically space safety, providing tracking of object in space, currently using optical station in Australia and Chile. Just another overview what we do across the value chain, from launch today in Esrange, where we are in northern Sweden, a place called Kiruna. We have our center called Esrange Space Center. Over there, we do launch, and we also do some scientific experiment, including balloons and suborbital launch. And we have a ground station there, or the main ground station there as well. Then in operations, as I said, we provide both manpower and ground station services, and also any kind of data management services on the operation side. On the downstream, we can help data collection and also distribution of data. And we do SSA data analytics. Today, we don't do so much on the Earth Earth observation data, but I think some of us who have known SSC a long time ago, we used to be also in remote sensing, but we have now divided and have a different company working on satellite remote sensing today. Some of the partners we have worked with, probably all the major space agencies around the world, but also private sector companies, large and small, going from Airbus to Planet to smaller space companies, new space companies, University of Tokyo, Hokkaido University. We have had several projects with universities as well, and we are always looking to actively be more, working a lot more with the new space and university sector to bring them into what kind of services SSC can offer. Before we even a bit more on our headquarter or the Israel Space Center. So this is where our main ground station is located, where we operate a very large number of antenna. On the side as well, we do sounding rockets, and what we do with sounding rockets, mostly scientific studies, microgravity experiments, student missions. And then stratospheric balloons. So if you're wondering what is stratospheric balloons, you probably have heard about the balloon that flew over the US. I think that was last year or year before. So these are balloons that flies very high above the atmosphere, maybe at 20 to 40-kilometer high. And these are mostly used also for us to do some experiment, maybe measure different scientific process in the atmosphere. Then at test bed, we are operating, as I said, test stands for rocket and stage test stand as well. We have also a pad for reusability and a planetary lander pad for testing rockets and also landers in the north of Sweden. And lastly, on our small sat expresses, we will be providing spaceport services for launching of small rockets and also reselling capacity on those rockets as well. So this is a this is a launch pad, what we call LC3A, 3B, and 3C. Will be where we'll be launching rocket from. We are in the very north of Sweden. Going more into the topic today, SSC Connect. We are a global ground station network. So we are operating ground station across 10 sites, which we fully own the stations or fully own the space. And then we have 8 sites where we have added as a partner station. Each site will normally have redundant network, redundant antennas, redundant uh, network management centers. So we are looking to provide service, a reliable, available service, and therefore we are operating, and therefore we are I would say one of the main service provider that is used by most of the larger space agencies. But as well, we are looking to also work with the new space and universities as well. We are operating mostly in S and X, like what Ota-san was saying, that we S and X are probably the most utilized today for the Earth observation missions. So it is, of course, we are expanding to Ka band as well. So, I mean, this is just some information. So most of our station operates an antenna around the size from 7 to 13 meters. We have some of quite few smaller antennas today because I think it goes to the history of the customers that we used to be working with. We are mostly operating receiving in S and X band with Ka in some station and Ku band as well in some station. With respect to transmit, we also uplink in S band in almost all station, but then we have uplink in X band and Ku band in some of the station as well. And we are looking to upgrade to include Ka band for lunar missions as well. Sorry. Yeah, so I think I was mentioning about Luna. So these are the sites that we are expanding on the larger antenna size to provide what we might be calling it Luna services as part of the Luna Exploratory Gateway standards. We are having 13 larger than 13-meter size. So most of the sites we already operate have 13-meter, but what is special about these sites, we will have X-band uplink and downlink on all these sites as well, which are aimed at mostly deep space and Luna's partner. We are also operating the larger antenna of 16 to 32 meter size as well for those kind of customers where we would need to communicate with deep space spacecraft. We will be also having a smaller size antenna designing at constellation players where we are rolling out the smaller antennas uh, in existing sites that we have. So we will be starting with S-Range and Inuvik and then expanding beyond that to the Alaska station and Punta Arenas slowly and as well as to Hawaii to provide more, well, more better, I would want to say, better pricing, better costs for customers who are requiring smaller antennas and mainly looking at higher volume per day. Ka band also, as I was mentioning, Ka band is as you were saying, it's upcoming, but it's also dependent on weather. So we have installed Ka-band antennas at existing 5 sites today, and we will be looking to expand Ka-band also for lunar missions in the long term. And going beyond that, we have also developed an optical ground communication system where we have installed 2 stations today in Western Australia and Santiago. As you're probably aware, optical communications or laser communication requires a line of sight, which means you would need to be in a place where there would be minimal cloud cover. So the station are currently being installed and commissioned, and we expect them to be operational next year. And then we'll be providing initially maybe some testing and integration services and going into commercialization around the end of 2025, possibly could be 2026. We would also be looking at how these stations turn out before we start to expand them to other stations around the globe, keeping in consideration, of course, the weather conditions or the cloud cover in those locations. What are the advantage of optical communication is you could have throughput possibly 10 times or more what we are achieving today in RF. So as satellite become larger, or if data generation becomes more and more, and a lot of data needs to be dumped at a time it's passing the ground stations. These are the advantages that optical communication could bring to, and we are talking about direct to earth optical communication. So it would require, of course, the satellite to have those kind of module as well. So what are we doing today on these stations? We have the optical station in Australia and in Chile, and we are looking to even uh, upgrade the Australian station to a larger bistatic design, and we are enabling both protocol, the CCSDS and the SDA on the system.
Ravit, you have 2
Yes,
minutes. 2 minutes.
sure. Okay. Um, Going back on the ground station, this is the coverage over the globe. As you can be as you see, we have almost a global coverage. And what we specialize in is the North Pole, where we have a station in S range, and Canada, covering the so every pass that passes over the North Pole, we would probably be able to provide up to even 30 minutes of communication. So a lot long downlink pass would be possible. And we wanted to just add what you want to think about when you're considering your ground station need. It's mostly driven by data. And of course, when you're driven by what kind of data, it would end geographical design, capacity, frequency. These are all factors to be considered. And all of these are something that we would work with you. We would like the operators to consider all this at the beginning of design of satellite to be sure that you're taking advantage of the ground station and not designing a satellite without taking consideration of the ground station at the beginning. So the different location and different requirement of power would affect the cost of the ground station that you would be needing, depending what frequency, what antenna size you would need. So I'll skip over a bit. Um, so we are now operating in different. So as you're saying, the different antenna size is going to affect what kind of missions you need, and these are also affecting by cost. So consideration is very important at a design stage of the spacecraft to be sure that you are taking care of all these factors. Software is something we are looking to effectively integrate. Any kind of integration with our station is done through our API and WebSocket, and therefore almost everything can be done automatically or using a machine-to-machine communication. And all our sites are connected through multiple communication chain, ensuring diversity and redundancy. And we operate always 3 NMCs, so they're always providing redundancy to each other. Lastly, I want to talk a bit about the RF license, where SSC, when they're providing the ground station service, we would be doing the license for you for the ground station site, and therefore there are different requirements for different countries, as mentioned by Naomi-san and Ota-san about, different countries have different requirements. Some countries don't need license for downlink. Some countries requires license even for downlink. Some countries requires that you have service area defined. Some countries it's optional. So these are factors that we would be working with you to be sure that all of these are taken care of when you are planning your RF licensing. And of course, we would it would be good if this kind of engagement is done early so that, as you can see, the period requires for each license is different. So therefore, as Naomi was saying, 6 months minimum, I would say if you can work before that, you would be able to plan what station you would want, what kind of capacity you need, what kind of planning you need to do with respect to the ground station to be sure you're optimizing it for your mission. Uh, that's my presentation for you, and I can take question if needed. I hope I wasn't
Okay,
time.
Ravit, thank you for your presentation.